So we're starting again with some kind of basic terminology, basic language of geometry. We've got here a segment. A segment is a piece of a line that has two endpoints, and it's named using those two endpoints. Got this blue segment. I made the points on the end bigger dots to make sure that you could see them, though you do not need to have them there. And I name it by doing a little miniature segment and then the two letters underneath it. So this one I could name segment AB or segment BA. The order of those two letters doesn't matter because it's the same thing either way. So the next part that I have here is array. Array is also a piece of a line, but this time it only has one endpoint and goes on forever in one direction. So it has the dot, if you will, on one end and the arrow on another. So if I put a label on here, I would have to name it writing a little miniature array symbol. We draw it going to the right. Don't try to match the direction it is on the picture. You must start the name with the endpoint. So it's going to be ray x something. And then for the second letter, it can be any point that that ray goes through. So in this picture, I only have one other point on there, so I would have to name it as ray xy. My other picture here, if I put some more points on it, so I could name this as ray, again, I have to start with an A, but I can choose, I could write ray AB or ray AC. Still naming the same ray. Opposite rays we don't talk about that often. They're two rays that share an endpoint and go in exactly opposite directions. So one in blue and one in red. Normally we would talk about that as a whole unit being a line. There are some definitions or some occasions where you might decide to talk about the opposite rays. One such case is here. In this diagram, pair of opposite rays. I could say ray CD and ray CB, or I could name that second one ray CA. I would not be able to name a pair of opposite rays that started with the letter A because I can only name things to the right of A, and then I wouldn't be able to do its opposite. For the segments, it says name all of them. Go ahead and pause this and try to see how many you come up with. Now there really are only 6 because I don't want to double count. So I'm going to just start with A here as an endpoint first. So I've got segment AB, segment AC, and segment AD. I guess that was from A to B, A to C, and A to D. So that covers all of those. Then I'm going to change my focus here and start with a different letter. So segment BA. That one's actually already named because that's the same as AB, so I'm not going to include that in my list. So instead, I'm going to keep going to the right here. So I've got segment BC and segment BD. Now I'm going to go back to, so I've done all the ones that started with A, all the ones that started with B, and now I'm at C. So segment CD. Again, I can't do like segment CB or CA because those are already listed. Because if you remember, for segments, it doesn't matter the order of the letters. Now for rays, order matters. So I start with an endpoint. Well, if I start with A, I can't name anything to the left. There's no other point there. So I can just name one ray going to the right, but I can name it AB, AC, or AD. Now if I go to B as the endpoint, this one I can name both directions. So I've got ray BA, it's going to the left, and I've got ray BC or ray BD, so that's going to the right. And then I start with rays that have an endpoint of C, so CD, or ray, I'm just going to say CB. Again, you could use CB or CA on that one. And then, kind of same story as what happened in the beginning. for my ray that has an endpoint of D, I can only name it to the left this time. So I'm going to name it ray DA. And again, I only have 6 then for this particular diagram. Parallel lines. I'm sure you've talked about this before. And most of you, if I asked you what it was, you'd say 2 lines that never touch. And that's mostly true. But we're older and wiser now, so we're going to add a word to this. It's actually coplanar lines that never intersect or touch. Either way you want to remember that. Remember, coplanar means they are in the same plane. So like the blue, quote, lines that are on your paper, I know they're really not lines because they end. We'll pretend they don't. They would be coplanar because they're in that same plane, right? The plane of the page. Then we've got these other things. So if we had to make a big deal about those being coplanar, there's a reason. Skew lines are non-coplanar lines that never intersect. Okay, we'll do some examples and talk about these in a picture in just a second. But then parallel planes are going to be planes that never intersect. And for that, most people think of if you had like a box, the top and the bottom, or the front and the back, or the left and the right as being parallel planes. So we've got our box right here, and I want to talk about parallel lines. And I'm going to choose line AB. Let's say AB. I made it into a line because I extended it. Is parallel. Okay, so that's our symbol for parallel. Some people will draw it straight up and down. I tend to draw it at an angle so that you know it's not an 11. Okay, so in the same plane, easiest place to start, maybe think of the top plane. So it's going to be parallel then to line DC. Now if I think of a different plane, maybe what would be the back plane here? Then that would mean that AB, my original line there, is parallel to line EH, or line HE. There is also another one on here. It's just maybe a little bit more sneaky, hidden. Has to be in the same plane. But remember, not all planes can be drawn in a picture. There's the slanted plane that kind of, cuts through the middle like a ramp. And that plane be here. And if you can think of it as a front to back ramp, AB being at the top, back of the room, and then FG is at the front, bottom. So that means those two are actually parallel as well. So our original line AB is going to be parallel to line FG. And sometimes that's the hardest one to see because when you first look at the picture, it doesn't look like they're in the same plane. But it is. We just have to remember that not all planes can be drawn on one figure. Now what about those skew lines? Same box diagram. And you know what? I'm even going to start with the same line. So line AB, we don't really have a symbol for skew. Skew to or skew with. Well, they're not in the same plane, but they still don't ever touch. So this would be an example. Remember that blue line is kind of at the back of the room or on the back of the box. The red line is going up and down at the front. Okay, so they are never going to touch, but they are not in the same plane. Try to think of another one before I say it on here. I'm going to say another option would be line CG right here. Again, going up and down, so it's going a different direction, and it's at the front. So that blue one, as we talk about it on the page here, kind of goes across left and right, and it's at the back. So there is another example. Let me erase these other ones. And we're just about done here. Would be GH. It's kind of going front to back. It's going to go through that back plane underneath the AB line, so they're never going to touch. So line GH would also be skew. And then as many of you can see, we've got some other options. For instance, line FE. And there are other ones that could be listed as well. Oftentimes they'll say name 1 or name 2, give you a number to shoot for. And then we'll get into some other diagrams, but that gives you a basis for talking about what can sometimes be difficult are those 3D box diagrams. Relate them to a room that you're in the front and the back, and maybe you can kind of see where things are that way instead of trying to only look at it on that two-dimensional page.